Good afternoon, everybody. Jeff or Tony, can you hear me?
Yep, I can hear you, John.
Cool.
Yeah.
So, everybody, welcome to the sixth webinar that the FAA account team is holding uh, for Red Hat. Again, those of you that are new to these, my name is Jonathan Beach. I'm the dedicated solution architect covering the FAA as well as some other accounts. And again, as always, we have another great webinar. It's probably our biggest product right now. It's very it's a very cool product, and that is Red Hat OpenShift, right? So, but before we get started, I just want to go over some ground rules. First, by default, we cannot hear you. We mute everybody's mic as well as the video feed. We ask you to put any questions in the Q&A section of the window. There is a chat function that we do see and monitor, but if you could please put any questions in the Q&A, we get a report afterwards, and this way we can follow up with you if we're unable to answer your question today. And during that time, Jeff Thompson and I will be answering any questions as we go through, as well as our presenter will be pausing at various spots throughout the presentation to answer any other questions that Jeff and I are unable to answer. And then at the end, we'll go ahead and wrap up any questions that have yet to be answered, as well as send out some contact information. During the presentation, I'll drop my email address in the chat function. This way everybody has it. They can reach out to me if they have any questions. Jeff will do the same. So that's all the ground rules. So let's get started, right? So today, we welcome back Tony Bow. Many of you remember Tony from our Ansible webinar. But Tony is an automation and cloud platform specialist solution architect. He's going to introduce everybody to Red Hat OpenShift. So with all that said, Tony, you're clear for takeoff.
Hey everyone, my name is Tony Bow. Good to see some of you again. So for those of you who don't know who I am a cloud specialist and specialize in automation, everything around the cloud, basically. So not just like writing your scripts, but deploying applications and how we are moving from a traditional type of network to a more modern dev/CI/CD type of cloud-first environment. And so for those of you who are familiar with OpenShift, it is built on Kubernetes, and Kubernetes is one of the leading container orchestration platforms in the industry. And it all started off with Docker. And so some of you may be new to Docker or you're already familiar with containers, but we've come a long way from this idea of having a monolith of an application being housed inside a VM all the way to being able to use the same Linux technologies to kind of refine the way we segment out not only just physical utilization, so CPU, memory, and so on, but functionality and being able to use that type of segmentation to create containers and be able to make applications less monolithic, more scalable, more cloud native. So instead of just focusing on standing up your VM, you can focus more on standing up your application and not worry about the underlying infrastructure. And so let's jump into the presentation. Here's the agenda for today. We're going to talk about the modern challenges, really dive into like OpenShift. Demonstration would include like a little walkthrough, and then we're going to dive into the components of OpenShift themselves. I'm not going to list out all of these topics, but you get the idea, right? Today we're going to learn more about what OpenShift provides, and OpenShift 4.7 GA actually just dropped yesterday, so we have a lot of new features. I can also share a roadmap with you all. We can share that via email, but these slides will be available as well after the call. I'll forward them over to John and any other person that needs it. But without further ado, our problem. So, I mentioned the monolith earlier, and really what is challenging about having a monolith is that, our application is up, but, you know, it's in this VM and it's actually quite large. And in order to take down, upgrade, or migrate different items related to this monolith, it takes a bit of work. And a bit of work is an understatement. Really, you have to consider all of the possibilities of, all right, well, if we decide to upgrade this package and this VM, is it going to break anything? Or we want to make this code change, is it going to cause customers to see something different? Or is it intending on changing what we wanted? Like, what is our intention behind doing all of these different things? Well, we're in a world where technology moves every day and grows every day. And so we're trying to keep up with development and integrations of newer technology. And so part of this challenge is really where the industry is headed. We have a lot of growth ahead of us, and the organizations that we're in are trying to push us to modernize our applications. And so that leads us to kind of trying out new things, and it leads to learning about what doesn't work and what does work. And when we experience the what doesn't work, we experience reduced service quality, and we'll have downtime and a lot of other problems come up. But part of the challenge is solving these issues. So containers are this. You can see it on the screen, but really a container is just like an isolated application, an isolated service. When you compare it to the context of a virtual machine, well, inside of a virtual machine you have a VM is basically like an isolated operating system that has your services and has your application. But imagine in a scenario where you have a bunch of containers, and you are very concise about the service you need, the application you're trying to stand up, and you have multiple of these for redundancy and high availability. When you start making these comparisons, you'll get a lot of these benefits: multi-tenancy, encapsulation, ephemerality, so on. The idea is, we're not necessarily getting rid of VMs, but we're decoupling the way we're traditionally using VMs for applications. So instead of housing it inside a VM, we house it inside a container, and then we can have many instances of that, and then we have a much more finer control over how we scale, deploy, and really develop your applications. So when we're talking about deployment, we're talking about scale. Having one or two is quite easy, right? You have one or two VMs, that's easy to manage. Okay, maybe our organization grows and now we have 10. All right, that's not too bad. Then it goes to 20 and 30. Managing that many VMs is already a hurdle, right? And there might be people dedicated to doing that, and so that might not really be an issue. But as your organization grows, we typically scale, by adding more people or just by finding new ways to kind of manage not only the VMs, but what's housed inside of those. Well, the same thing with containers, right? Eventually we're going to have one or two containers in our sandbox, and we feel a little bit more comfortable. We're going to deploy it to dev or maybe production, and before you know it, you can have like 100 containers, right? With containers, it's much easier to deploy these things that we used to deploy on VMs. And that's really a large change, right? What it takes to stand up like 10 VMs, you could probably do with 100 containers. And so, long story short, how do we manage scale? How do we manage the complexity of just having these many containers, these many applications, right? We know the differences between a VM and a container, And now we're trying to see the benefits of a container, but now we're also running into the issue of, all right, well, now we have a lot. What do we do? Well, let's take a step back. To find out how we need to manage the complexity of a container, what goes into an application, what goes into a container? Well, we have, a developer, this is our traditional kind topology of, all right, we have developers, we have some source control repository for where our application code is being housed and maybe a CI/CD pipeline. And ultimately, the output of that is a container that gets, deployed. And that question mark is kind of facilitated or kind of indicating, all right, well, something needs to manage that type of deployment across our infrastructure. So what goes there? And, I mentioned, we have one and then we have many, 100, 3, and so on. You get the point. Something still needs to be there to kind of deploy it across our infrastructure. We can also use this topology to kind of represent our VMs, right? So for VMs, we have Rev, we have VMware, Hyper-V, a lot of tools and platforms to kind of help us manage these VMs. Same idea, right? We have a lot. So how do we manage it across our infrastructure? Well, the community came up with Kubernetes. And Kubernetes is a container orchestration platform. I'm going to use Kubernetes to manage my infrastructure and manage the orchestration of these container images that get developed and pushed through our image repository. And, it's going to be automated for us. So Kubernetes handles the deployment, the scaling, and, ultimately the manage of our applications. That's great. Now we have a platform that, can stand in for VMware, but for containers. So we have this new platform, Kubernetes, and we're trying to really operationalize our containers. And, we have different containers on different teams. Um, you know, Building these containers out onto the infrastructure isn't just deploying it onto a physical machine or a VM or anything of the like. We also have to consider, all right, networking. What kind of storage are we going to use? Role-based access control. All right, what security policies we want to apply? All right, well, kind of address the issue of, all right, well, if we want to scale out to multiple containers, hundreds, thousands, all right, we have Kubernetes to do that, but what about all of the other stuff, right? In the enterprise, it's not just standing it up. We need to be able to somehow tie in all of these other items, security, networking, storage, and miscellaneous platform tools that we already are using. So this image is kind of representative of that, right? We have all of these containers that have all sorts of stuff inside of those. And we don't know what's inside, but we need a way to kind of move them onto the right ships and have them sent out or maybe bring them in and also know that we're sending out the right ones to the right people. And so all of these kind of come back to the application inside a container, right? We have to be able to do that in some way or form. So this is what we need to operationalize containers. We have our underlying infrastructure, we have the OS, and then we have the runtime for creating and running the container image, and then everything in between to the container. And I'm sure some of you have already seen, these series of slides kind of demonstrate, all right, well, this is what we need in between to kind of scale and deploy and manage our new way of developing applications and deploying them. I mentioned before, networking, storage, registry, those are really fundamental things inside the enterprise that we need to kind of work into, right? Those are the things that don't change, or they do change because we have to configure them, but they're always needed, is what I meant. And then we have our container orchestration, and then we're considering our CI/CD pipeline, our build automation. Service catalog is really, all right, well, what else do we want to use along our application? And then self-service is more so around who accesses this? How do they use it? Or how are other systems and platforms interacting with our container orchestration platform to kind of deploy things, build things out? So think like ServiceNow or maybe some sort of uh, again, catalog for teams that you're managing so that they can deploy their own stuff. Well, Kubernetes is only a small part of like this stack. So out of the box, vanilla Kubernetes does provide you a way to kind of build and run these containers. And maybe a bit of networking and a bit of storage. But does the networking that it provides fit your needs? Does the storage it provides or the plugins it provides fit your needs, right? And part of what's cool about Kubernetes is that it contains a lot of ways to tie in other platforms, systems, whether they're physical, infrastructure related, or just software. So it's more of like a plug and play. As you can see, this diagram kind of demonstrates that Kubernetes is part of that underlying operationalizing platform. So when you add all of these other components and you add all these components with Kubernetes, you have OpenShift. OpenShift encompasses all of these things. Really, it's all software driven. For each one of these little boxes you have there's a underlying software component that handles that for you. But it's not just like a software component we stuck in. It was built from the ground up along with Kubernetes and with the enterprise in mind. And so what that means is, well, I have all these existing tools I want to tie into my new platform, kind of like when you integrated VMware into your environment. Like you have to tie in your networking, your storage. Maybe your storage is Trident from NetApp, or maybe it's Nimble storage, right? You got to tie that into VMware and make sure it ties into your Active Directory and considering authentication, making sure like the right people have the right access and so on, right? Same thing with Red Hat OpenShift. Able to tie into your enterprise applications and existing platforms. So it's Kubernetes built for the enterprise. And to break it down a little bit, you get that self-service, it's multi-language. What that means is it supports a lot of languages. There's a lot of built-in automation. It's a platform not just for like deploying your containers and managing them, but giving other important users of the organization, developers, analysts, scientists, a way to collaborate on the development or the maintenance of your application. Multi-tenant, so you don't have just individual people, you have multiple teams, and you can have multiple organizations across the enterprise use it together and have your little own silo. You can share different things, different components, not necessarily everything, but it's powerful because those role-based access controls give you that security and really a way to not completely silo yourself, but be able to share the components that you think need to be shared. And it's open source, right? So you have the power to jump on GitHub to see like the development of how Red Hat is contributing back to Kubernetes and how it's building the most recent version of Kubernetes into OpenShift along with all of the other Red Hat exclusive components. And so part of this development cycle is 1 to 3 months of hardening of the actual Kubernetes release. So the most recent release is 1.20 for Kubernetes, and we don't just immediately integrate that into OpenShift. That just doesn't jive with the way a lot of organizations operate. They need something stable. You guys need something stable. And so this um, series of months for hard. So OpenShift 4 has a 1 to 4 months ish type of hardening. That time was actually supposed to be 3 months, and it's varied a lot based off of last year's different events, COVID, and so on. And so timing had to change a bit, but we're getting back to that consistent release cycle. But the idea is, you have your bug fixes and patches and new features, integrations, and so on being available to um, each version of OpenShift. And it is maintained and updated with this thing called over there updates, which I will kind of delve into in a little bit. So installation, how do we install OpenShift? But before we jump into that, I'm just gonna take a quick breather. We have about 40 minutes of content to go through, and I'm gonna check the chat to make sure, I'm not skipping over anything.
So, Tony, we do have one question, but I'm going to hold off and see if you hit it later. It's about migration path from Rev VMs into OpenShift.
So it's interesting because, last year, if we were, presenting on this, we would say OpenShift is for containers exclusively, and so is Kubernetes. But as of, I believe it was end of November or December, OpenShift is not exclusive to containers. Actually, the platform itself is now a orchestration platform for containers and virtual machines. And so you can now manage your Rev VMs, and it's not just Rev VMs, VMware, and so on. You can manage your VMs inside OpenShift. So it needs OpenShift bare metal, and we'll talk about the different supported platforms. But you can use container constructs to kind of apply configurations to your VMs. So secrets, config maps, deployment schemes, routing mechanisms, all of the good stuff that have been modernized, you can immediately use that for your VMs. Hopefully that answers your question. So, if you guys have any other questions, please post them in the QA. I do have a little section on my other monitor to keep track of the notifications. All right, so jumping back in to installation, these are the supported platforms. We have two types of installation. IPI is the full stack automation. Basically, you just throw in your credentials and make sure the account has the right permissions, and the installer will reach out to that provider and automate your installation. And then maybe that is a little too permissive for you. So you want to use the UPI. So UPI is for environments where, all right, hey, I want to define the networking. I want to define a specific DNS server for the environment to use. I want to define specific nodes to come up and so on. That's where you would use the UPI. So your OpenShift environment is up, and let's say you set it up last week. Yesterday, 4.7 just dropped. So how do we go from 4.6.13 to 4.7? Well, new thing with OpenShift 4 is the over-the-air updates. Just kind of think of it as your iPhone or your Android device. Hey, I have an update. Please click this button if you want to update your entire platform. And there's a lot of rules in place for the cluster to update. So everything is built on an operator, which we will delve into. But because everything's built on an operator, every individual component has its own update scheme. Hey, I'm trying to grab this package. This is what I need to update. I need to bring up a specific service inside inside a container before taking down the previous one. And so think of like a rolling update for your application. Now we're doing like a rolling update for an entire platform, but it works because everything is containerized inside OpenShift, and every single application and service that's containerized has an operator that manages the lifecycle of that application. So with the installation of OpenShift, we also have managed offerings. So if you're interested in having someone else manage your OpenShift environment, these are the providers that are currently available. So AWS, Azure, IBM Cloud. Red Hat has its own offering, but we deploy it onto Google Cloud and AWS, and then the last option is you yourself manage the platform. So here are options as well as to how you can consume OpenShift. So we got to start off at the bottom of the stack before we kind of delve into operators, but OpenShift runs on Red Hat CoreOS. CoreOS is based off of RHEL 8, and inside OpenShift, the CoreOS version has a one-to-one parity with the Red Hat OpenShift platform version. So when OpenShift is on version 4.1.6, CoreOS is on 4.1.6. And you can kind of think of CoreOS as your piece of hardware, in a way, your software / hardware that's running OpenShift. OpenShift will manage the changes to CoreOS. You don't need to jump in, you don't need to shell in to make a change to any packages. You certainly can install things on there. There's ways to apply agents and configurations, maybe like governance to your CoreOS machine. You do that through OpenShift. So think every update to the OpenShift platform includes a firmware update to your CoreOS machine. All of the masters and workers are CoreOS. You can optionally use RHEL 8 as the operating system for the worker nodes, but the masters are exclusively RHEL CoreOS. So operators, kind of mentioned them earlier, and they include a lot of functionality. They span a lot of different verticals, but really what an operator is, or there's a lot of operators for everything. And then Red Hat has a way to certify operators. There's a certification program, and there's a set of community operators. But operators are a way to build full lifecycle management for your application. How do I update? How do I reconciliate problems with the application? All right, I'm experiencing this error code. Well, if I built an operator and I recognize this error code and there's currently no fix for it, maybe I can build like a patch, or maybe not a patch, but a workaround into the operator. Or maybe it's not a bug, but there's some sort of timing thing that needs to be handled and the operator can handle that. Or I want to do health checks and so on. The operator is for full lifecycle management. I might have mentioned updating. I'm going to say it again. Oh, there's a new version. There's a new image. I'm going to pull that and update the current deployment. That's what an operator does. And there is a Go SDK and a Ansible SDK for the operator framework. So you yourself can build operators for your own applications or for other teams inside your organization to consume. So maybe your team is responsible for a service, an application to operate, and you guys decide that you don't have the time to always go out to different sites to manually install it. So you build an operator, and the teams that own the OpenShift platform can install the operator, and the operator will automatically download the right image, maybe add a little bit more configurations, and you might need a little bit of custom configurations depending on the data center you're downloading it to. And bam, now you have an operator and an application that's up in specific data centers and is managing itself. It might be even sending you health checks, keeping you informed on the operation of the application. So Operator Hub is basically your catalog to consuming operators from your organization, the community, your ISVs, and Red Hat. So think of a Red Hat product you might have today. There might be an operator for it. There's an operator that's in development for Ansible Tower. Ansible Tower can be deployed on OpenShift. Maybe you're using Process Automation Manager. You can easily deploy it on OpenShift through Operator Hub. And obviously all of the third-party vendors will have their own operators for their own applications to consume, but this is how you would access that, whether it's a paid operator or a free operator. You have a lot of flexibility here. And as an admin, whoops, I mixed up the slide. I'm going to jump back to that real quick. As an admin, you have full control of who gets access to the specific application that you installed via the operator. I'm going to jump back. So from a developer point of view, when I access my developer catalog, it might include some of the items that the admin installed from Operator Hub, Postgres, or maybe serverless, OpenShift pipelines, or maybe like a component of some monitoring application. Now, as a developer, I have access to all of these newer tools that I requested from my admin, and I can deploy them into my own namespace, which is pretty great because maybe you have your in-house golden image, container image that you want the developers to use. You can use that, build a template, add that image into the template and add it to the developer catalog, or use the Operator Hub to get a standard image or a standard application and have that available for your developers or teams. So a lot of the Red Hat operators, when installed, actually apply UI changes to OpenShift, which is pretty neat because you install an application and now you have a way to kind of manage that application within OpenShift. So managing your virtual machines. OpenShift by default doesn't include the virtualization factor. You can actually, once you deploy it on bare metal or a supported cloud provider, you have to deploy an operator to enable that feature. Or maybe you want to enable service mesh, or you want to enable cost management or OpenShift pipelines. All of them are operator based. And for OpenShift service mesh, a lot of these operators actually are available with OpenShift, so there's no additional fees with them. Some operators are paid, so think Quay. Quay is a registry that Red Hat also provides. Has a lot of really neat features. We can talk about it in a future meeting if you guys are interested. PAM is another example. Hey, I can install PAM, but I need a license for that. So for those of you who are familiar with Kubernetes or OpenShift 3, Kubernetes itself does not have a graphical interface. OpenShift 3 has a very different graphical interface. This new interface is based off of Patternfly, which is like the UX UI framework. And it's pretty nice. You can access all the components of OpenShift through an admin view or developer view. On the left side, there's a navigational pane. You can create operators to make changes to the nav pane and give your own application or what you deploy into OpenShift custom resources to kind of define a view for your team if you decide you want to go down that route. But really, the grapple reconfiguration is just a way to kind of have people easily consume the idea of container orchestration. And then as they become more comfortable with visualizing containers, they can start utilizing a lot of the features and functionalities that come out of the box with OpenShift, and eventually a lot of features and functionalities that can be installed via Operator Hub. We talked about the admin control. Admin control isn't just for managing what the developers see. You can define very granular role-based access controls for incoming and outgoing traffic, what applications have access to different resources and components, who has access to deployments and containers, and a lot of different things. Just, think from an enterprise. What do I want to control? How do I want to manage this access? And then with, self-service for developers, really like a lot of these things can be automated from a developer point of view. And think of the times when you had to request a VM from your team lead, or maybe the team that manages the VMware infrastructure or the RAI infrastructure. You have to go through a process. But with your underlying infrastructure already available to OpenShift, and hopefully you have your RBAC in place for defining what developers can access, they can just go in and deploy their own stuff in their own namespace. Maybe they have a sandbox namespace that they can test things out with, that changes they make shouldn't matter, right? They can stand up different databases backed by real physical hardware. It really depends on what you want to provide for the developers. So we talked about some of the broad functionalities of OpenShift. Do we have any questions?
Yep, Tony. So we have one going back to the over-the-air updates. As you know, the FAA has a majority of their systems air-gapped. What are the options for OTA with an air-gapped system?
Yep. So with Red Hat, we have a lot of organizations that have a lot of refined and strict security requirements. And so Red Hat for Government is a resource that we provide. It's a website that has like a lot of instructions and documentation on how you can set up OpenShift in an air-gapped environment. But long story short, you mirror your images. So because every component inside OpenShift is backed by an image, you can mirror those images from the Red Hat registry into your own image registry. And whenever you deploy OpenShift or you're managing your disconnected OpenShift environment, it will just point to your internal registry to pull those packages. We had another organization inside the FAA. What they did was they proxied and some of the traffic to pull specific images, and I believe the environment was actually in AWS Gov, and so it was pretty restricted in the sense that it was technically completely disconnected in a way. They were proxying items over to their registry, and then the AWS environment, OpenShift environment, had to grab all their updates and images from that specific internal image registry. I know that was like a kind of hopefully not confusing explanation, but that's basically it. You just get the images internally, and then you point your OpenShift environment to it. And that's the same for Operator Hub as well. You can mirror specific items from Operator Hub, so the location, and if a user needs access to specific images or an admin wants to download a specific operator, they would mirror that operator image. Any other questions? Nope. Okay.
No, that's it for
All
me.
right.
Yeah.
So we have about 20 minutes left. I'm gonna speed up a little bit. Um, a lot of organizations, when they deploy OpenShift, actually just use it to house their CI/CD tools, and you can certainly do that. CI/CD is great on OpenShift. If you have existing CI/CD infrastructure, you can, create like a hybrid infrastructure here where your OpenShift environment is the destination for jobs to run and then applications to be deployed, or maybe it's just the environment for building and developing your applications. So it just houses all of the CI/CD components and production applications, or an existing production infrastructure. In a modern environment, you're most likely to house everything inside OpenShift and have different OpenShift environments to act as dev, lab, and production. Here's another deployment scheme for CI/CD. You don't necessarily have to put all your CI/CD components on OpenShift. You can just have it as the endpoint for your image, and OpenShift will handle that deployment, the scaling of your application if needed. So maybe you only have one OpenShift environment and that's your production, and you send everything there. I don't recommend that. You typically always need a lab environment for any type of infrastructure or platform you stand up, because you're going to be making changes, you're going to test out configurations, and it's always nice to have another environment that you can kind of attempt to break, not intentionally, but you're going to be making changes. So testing out those changes before it goes into production is always like a best practice. So you can have hybrid CI/CD, whether it's on OpenShift, part of OpenShift, or external to OpenShift. OpenShift itself comes with a DevOps platform. So you can go through Operator Hub to install the Jenkins operator and the Tecton operator or OpenShift pipelines. So OpenShift images or Jenkins images are available as of, I believe, yesterday, and I could be wrong, it might be a month from now. There is a Jenkins operator that is going to be supported by Red Hat. But for now, it's going to be a tech preview. We don't have an official GA date for that yet. But basically, you will have an operator that will handle the lifecycle of your Jenkins image and deployments. So you can define different deployment scaling, configurations, where do you want to hook it up to, specific backend, or you can use the cloud native pipeline that I love to use and I love to talk about, Tecton, also known as OpenShift pipelines. So with OpenShift, you can have out of the box CI/CD. And then you see this little squid over here, this orange squid. So OpenShift GitOps is basically Argo CD. Argo CD is the upstream. Argo CD is a very popular continuous delivery platform for applying configurations and basically doing all things GitOps for Kubernetes and OpenShift. OpenShift GitOps was announced to be in tech preview yesterday as well. So now you have Tecton and Jenkins for your CI and Argo CD for your CD out of the box with OpenShift. This is what OpenShift pipelines looks in the web console. The navbar would actually be on this left side here. You click on the pipelines tool and there's a few tabs, but you can kind of see all of the different pipelines you build out and whether they're successful or not. Some of you might be familiar with a version of this or a type of this. I don't know any other way to say it. I'm losing the words in my dictionary. In OpenShift 3, there was a way to kind of visualize Jenkins inside OpenShift 3. And this is actually intentional for OpenShift pipelines and Jenkins in OpenShift 4. So you kind of see everything right from the OpenShift dashboard, as opposed to in OpenShift 3, you'd have to click on something and then it takes you to the Jenkins platform to view it. Here's an example of a CD pipeline. We're going to briefly go through this, but basically you have a developer. You're pushing code and it kicks off a build. Basically goes through the entire pipeline. Build the image, deploy it onto dev, push the image to some artifact repository. Maybe we promote a test, and maybe we do another promotion, and eventually it gets to prod. Well, you have a pipeline, and you have different gates in place, and you have different environments that you push to before it gets promoted to prod. What that represents is an inclusion of a lot of different platforms and tools, right? Jenkins or Tecton might be your delivery pipeline. So it might be the underlying pipeline that handles, all right, well, I'm going to build the image in this location. I want to push it here, and then it goes to the next part and so on. With OpenShift 4, integration of a lot of these tools is much, much easier. Actually, Red Hat provides a consulting service as of December of last year to come in and build out a secure software factory. And it comes with a lot of tools out of the box. But the consulting service really their goal is to give you an out-of-the-box working pipeline in the case that you don't have an existing one. And if you do have an existing one, what we do is we plug it in like a puzzle piece it should work, as in we fit it to your needs. I don't know why I'm losing my thoughts at the moment, but basically consulting will fit the pipeline to your needs if you already have existing pipeline tools. If not, then we deploy one for you and fit it to your application needs. So, we talked about the pipeline, we talked about the operator hub and some of the GUI changes. Service Mesh is a really popular development platform, but it's not just for development, it's for actually monitoring and implementing different security policies around your applications and just defining how application and microservices interact with each other. And so OpenShift Service Mesh is available for you to download from Operator Hub. And it's a few components, or more than a few components, but it allows you to do all the way down to the application using this thing called a sidecar, which is another container that gets packed into a pod. And if you're familiar with Kubernetes or OpenShift constructs, a pod is what houses a container. It's what Kubernetes uses to automate the container. So this pod construct can have one or two containers, and the sidecar is a container along with your main application there that handles the routing or applying different components as part of the service mesh. Using this sidecar mechanism, it's able to basically draw out your topology of applications, pretty much giving you a service mesh, like a way to kind of visualize how application traffic operates, and you're able to do different types of rollouts. You're able to have a more granular control around how these applications are communicating with each other at an API level. And it integrates with different API managers. Red Hat has one called 3Scale. But yeah, this is OpenShift Service Mesh. It's a very developer-centric tool. So serverless. For the data scientists or people who want to just be able to run their function or be able to just run a quick command, OpenShift serverless is where you're going to be able to do that. Um, it's available as an operator, so it's not enabled out of the box. You just have to go to operator hub to enable it, but it gives you the functionality or gives you the serverless platform so that you're able to kind of execute um, items on OpenShift as if you were to access like Lambda on AWS. So, we have 10 minutes left, and I'm going to close off with Red Hat Advanced Cluster Management. There's actually a lot of features of OpenShift and a lot of platforms and components that we didn't get to manage. We didn't get to talk about today. And I went over like some of the major ones that people are currently using today in the industry that are very popular. So service mesh, serverless, CI/CD is really big with Kubernetes and OpenShift. When customers and organizations and different people who manage these environments have multiple versions of these environments, it's they run into the issue. Well, how do we manage our platforms from a single pane of glass? Red Hat Advanced Cluster Management is another offering that allows you to manage OpenShift, whether it's a managed version of OpenShift, whether it's a um, OpenShift environment inside your specific cloud provider you have on-prem. It consolidates that into the ACM platform. ACM basically deploys an agent, a pod, a container onto the other OpenShift environments that it manages. And from the ACM dashboard, you're able to really control all of your OpenShift environments. And by the way, it's not limited to OpenShift. It can manage Kubernetes as well. So what this means is once you tie in your cloud provider, the ACM or your infrastructure, ACM is able to automate that installation of OpenShift. Now, not all cloud providers or not all providers are currently supported at the moment. They're on the roadmap. The main ones that are supported today are Azure, Amazon, and GCP. You can connect existing bare metal or VMware environments to ACM so they can manage that. We were just talking about the context of installation, so automated installation through ACM. But once you have your environment under ACM, you can really define a lot of constructs. So constructs such as governance. I want to apply certain policies across these OpenShift environments. I want to be able to test this application deployment on this other environment. You can access the CLI from this dashboard for a specific environment. You can look at the YAML policies and modify them on demand. You basically manage the OpenShift environment as if you were there, and multiple of these. So you get to see all of the metrics across your OpenShift environments. So think, all right, well, I'm in a disconnected environment, but inside this disconnected environment, I at least have access to, I can at least manage all of my OpenShift environments in one place. So lab, dev, prod, and maybe I have one out in AWS, Gov, or I have one in Azure. Easily stand up an environment, easily apply existing configurations from one environment to another. So the governance I mentioned before was around existing compliance policies. So think CIS, think NIST. Out of the box, it comes with a set of policies that you can immediately apply to your OpenShift environment. These policies, it can check if it's compliant, and you can also set it to, all right, well, let me know if it's compliant or not, and you can make it remediate that, so it'll immediately try and make it compliant. You get visibility into the actions and the components of what's being applied. You can create your own policies. So basing it off of existing policies, you can see how things are being applied and what changes, and you can apply your own. And advanced application lifecycle management. So imagine if you had an application you want to deploy in multiple clusters, or maybe you have an application you want to be able to deploy across clusters. This is going to be your way of managing that application. Now, you're not just managing the OpenShift environment itself, you're managing applications that span across multiple environments. So maybe you have multiple prod environments or multiple environments that just have different services, or they belong to different teams and they need to interact with each other. You can visualize that here. And really, if we bring all of the things we talked about today together, we have the OpenShift container platform. ACM is at the top. It manages all of our OpenShift environments for us. With OpenShift itself, we have all of these platform services, application services, developer services, and what we talked about today is a drop in the bucket. There are so many more things that OpenShift integrates with, that are certified with, and supported with, that while we didn't get to manage today, like as long as you have a vested interest in kind of finding out whether it fits into your needs. Whoops, accidentally triggered my standing desk, but yeah, like, it's there. It's a platform with full capabilities for your development organization, or maybe you're trying to fit the needs for managing other teams. You can use OpenShift for a lot of different things. It's built on Kubernetes, and you could say OpenShift itself is Kubernetes, but Kubernetes is certainly not OpenShift. OpenShift comes with a lot of components that we talked about today, like over-there updates. You don't get that with Kubernetes. You have to go through the process of managing multiple different nodes and updating them individually. But the idea is that with OpenShift 4.7 today, we've refined a lot of these different components, and we've been able to uh, drive it from an automated standpoint. So it just all fits together like a giant puzzle. And you can deploy it onto any environment and manage it from a single pane of glass, whether it's the ICD that you're focusing on, or maybe managing production workloads, dev workloads, people, data, assets. It can do everything. Oh, and one thing I forgot to mention is Windows 2019 Server is supported as a worker node inside OpenShift. Um, Now, it's not supported on all providers at the moment, but that is on the roadmap. So if you're interested in Windows Container for Windows Server 2019, that is a conversation that we can have with you. And so when I mean everything, I do mean everything. And if you don't have a Windows application that's in 2019, that's what OpenShift virtualization is for. So take your existing Windows application that's already in a VM, move it onto OpenShift and manage it with OpenShift. And I concede the floor for anyone who wants to ask any last minute questions, and I can answer there, or we can follow up in an email.
All right, Tony. Well, thank you, Tony. But So with that said, I would like to thank a few people for making this happen today. The first one is Tony. Thank you again, Tony, for coming out a second time to help me out and talk about OpenShift with to the FAA. It was really good, and I'm sure this should lead to deeper conversations in the future with various programs. And I hope we can do more webinars, deeper dives into various topics in OpenShift in the future as well, Tony. Thank you, Jeff Thompson, for taking the lead to make this happen today. Also want to thank our partners, CDW and DLT, that also helped make this happen today. We greatly appreciate everyone's efforts to put on this webinar. I would like to plug our next webinar. It is March 11th. Melody's going to come on and review the training options that are included in the Red Hat FAA ESP, as well as some other training options that aren't included. There's many options there, and I really think everybody should at least join for a few minutes to listen to Melody and to see what we have to offer. And sort of what Tony was saying earlier, we do have consulting options available. Tony mentioned just one of the many options we have for OpenShift. So again, if you guys are nervous about working with OpenShift, we definitely have some people to come in that can help you, hands on keyboard, to show you how to do things versus just us dumping this massive project on you and walking away. That there are some great services there, and I was lucky enough to have one in my future or my past position. One last plug: Red Hat Summit. It's virtual again this year, and it's also free. So if Jeff, if you don't mind dropping that link in the chat real quick before everybody drops off, I forgot to do it earlier. Myself, the rest of the Red Hat account team, we thank each and every one of you for joining us today. And like I said, feel free to drop me a line. Actually, let me put my email address in there as well. So the first one is the summit. The second one is going to be my email address. If you have any questions, comments, concerns, always reach out to myself, Jeff Thompson, Tony. Again, so thank you for coming out. We'll see you guys on March 11th. Thank you.
Thanks, everyone.